Welcome to week 7 of remote learning for Math 1. This week our topic is linear regression, also known as line of best fit, which we touched on last week. Your homework this week is going to be another Desmos activity, and I will give you the class code at the end of this video. Due to the Memorial Day holiday on Monday, my office hours this week are Tuesday through Friday from 1 to 2 p.m. So please let me know if you need some extra help. As always, I'm happy to set up individual Google Meets for any of you that want to see me in person and work through questions. So you may remember this slide from last week. We had these 3 different scatter plots, and we talked about what the line of best fit would look like. And so I'm just going to briefly sketch these. Again, for the first one in green, and again, not perfect, but the line of best fit may look something like, let's try that again. Might look something like this. And as we talked about last week, that line is, quote, going up the hill. So that would have a positive slope. So this is what we call positive correlation. The one in the middle with the kind of reddish dots, if I sketched in my line of best fit, would look something like that. Those dots are going, quote, down the hill. So that would be a negative correlation. And then the last one, the dots are just kind of scattered everywhere. There's no pattern. And this is the one that we say has no correlation. So I'm not able to draw a line of best fit. So let's look at a specific example. You may remember the ice cream problem from last week. We're just going to go into a little bit more detail. So first it tells us to examine the scatter plot and table below. One thing I want to draw your attention to, which I touched on last week, is the x-axis is measuring temperature and the y-axis is measuring sales. And this time we do have the table, and last week I think I used sales to be the number of ice cream cones sold, but now when we look at the table, we're actually, these numbers represent the amount of money, so how much they're making in ice cream sales. Another thing, if we look in the bottom left-hand corner, we are used to that spot being 0, 0, the origin, but notice in this example, on the x-axis it is 90, and on the y-axis it is 40, so we have to pay attention to that. So the question in red says, do the temperature and ice cream sales have a positive or negative correlation? And as we can see, these dots look pretty much like, and I think you will agree, are going up the hill. Again, I just did a rough sketch there. And so I would definitely say that this scatter plot has a positive correlation. Again, the actual values for the ordered pairs of each of those dots is listed in that table on the left. The second question here says, do the temperature and ice cream sales have a strong or weak correlation? Again, I'm just going to sketch in what might be the line of best fit. And based on that line of best fit, those points are clustered pretty close to that line. They don't lie very far away from it. And so as a review from last week, we would say that there is a strong correlation. Again, if the dots were not close to that line of best fit, that's when we would have a weak correlation. So now I want you to find the average temperature and average sales. Just remember to find an average. You add up all the numbers, and then you divide divide by how many pieces of information you have. For instance, if we were going to do temperature, so if we were going to find our average temperature, we would take each of the temperatures, 93 plus 94 plus all the way through 105. And then if we count those up, I believe there are 13 different temperatures. Again, you can use, many of you will probably just use your phone for this to add those numbers together and then divide by 13. Remember to press enter. You can use Desmos as well, whatever works for you, but some type of calculator. Add 93, 94, 95, 96, all the way through 105. Find that sum and then divide by 13. So I'll give you a minute to work through that. All right, I came up with 99, and that is degrees. And if you look at the table, this is measured in degrees Fahrenheit. So that is our average temperature. All right, over on the right, I'm going to find our average sales. So just like we did with average temperature, we're going to add up all the sales. So 60 plus 61 plus all the way to 112. Again, we've already established that there are 13 data points. I didn't mention, but with the temperature, I don't think it was exactly 99, but I just went ahead and rounded to the nearest whole degree. For the sales, for this one, since this represents money, I will go to 2 places past the decimal to represent dollars and cents. So again, if you will add the sales, 60, 61, 63, all the way through 112, again, remembering to press enter and then divide by 13. Remember, if at any time I'm going too fast, don't hesitate to press pause in the video. So I came up with, again, rounded to the nearest cent, $79.65. So average temperature is 99 degrees for this data set. The average amount of sales was $79.65. So this one says draw a line of best fit using the averages and write the estimated equation. So we have to recall that on the last slide, we came up with the average temperature and the average sales. And so the point that we came up with was 99, 79.65. So I'm going to do the best I can here to plot this point. So 99 would be a little bit before 100, and 79.65, so maybe right there. And so that's the first part. We wrote down the average, and now it tells us to draw the line. So this time, I'm going to be a little bit more accurate because I want my line to go through that point. So let's see how I do with this. Okay, so again, I've drawn a line of best fit, but instead of just a random eyeballing it, I use the average temperature, average sales point to draw that line. Now, it's asking me to write an equation, and so we reviewed this last week, but our point slope form, and I'll write that out for you again, is y equals m parentheses x minus x1 plus y1. And you may remember earlier in the year, I tried to get you guys to do the little chant, opposite x, same y. So that x1 and y1, we are just going to simply plug in that point that we just came up with. But what we will need then is to figure out the slope. So we can go ahead and fill that first piece in. So y equals, we'll leave a spot for the m, x, and it says opposite of x1, and since it was 99, this will be a minus 99, and then a plus y1, so it means whatever y1 is, and that's 79.65. But now we need to find the slope, and I want to try to use, well, I'll definitely use the point that I came up with my averages as one of my points. And then I want to use another point that it looks like the line that I drew goes through. And it kind of looks like it goes through this point right here. And that point is the 104 or 101. And so I'm going to create a table, since that's my favorite. So we have our 99, 79.65, and then our other point, I have chosen to use the point 104, 101. And now I need to look at the change. Remember, our slope is our change in y over our change in x. And so the difference in 101 and 79.65, that would be an increase of 2135. And then from 99 to 104, I think that's pretty easy to see. That's an increase of 5. So my slope, my change in y over my change in x, is 21.35 divided by 5. And so if I divide that in my calculator, I come up with 4.27. Again, not sure how accurate this is, especially with my sketch, but I do know that I was using the averages as one of my points and then one of the other data points. So this is my equation. And again, it is an estimated equation, not the actual one. But later in this video, we will figure out how to find the actual line of best fit using Desmos. So as I just said, we can use Desmos to find the more accurate equation as well as the linear correlation. And in the next few slides, I'm going to go through, and I've taken screenshots from Desmos. And so you may have to definitely press pause, maybe use another device, or kind of go back and forth with this, maybe take some notes. But I'll do the best I can to kind of walk you through this procedure. So you'll go to Desmos, and in the upper left-hand corner, there's a plus sign. If you'll click on this plus sign, this little box will pop up, and the first thing we want to do is create a table. So you will click on Table. Next, you're going to enter the data in the table. So again, this was from the previous slide. If you need to rewind the video, you can, but I have taken that table and typed it in here. Again, for me, I just typed in all the X's and then all of the Y's, but make sure you're taking your time to type these in correctly. Again, if you need to press pause to enter this data, please do so. All right, so on this next slide, it says by clicking on the wrench in the top right-hand corner, so that little tool, it says you can set the window to match the one given in the picture. And I always like to, when I'm using technology, to make the window match the graph that I was given. So once you click on that little wrench where it says x-axis, notice from the graph, the smallest x value was 90, the largest was 110, and in the graph it was counting by 5, so I made it match exactly the same. And then for the y-axis, the smallest y value was 40, the largest was 120, and it was counting by 20s. And so Again, this is not required, but so that it will kind of compare nicely to what we are given in the problem, I went ahead and set that up. Then just another little added note, we were finding averages earlier, and since I've got Desmos pulled up, I decided I would go through and show you that you can find an average. You may remember the average is called the mean using Desmos. So once again, if you'll click on that plus sign in the upper left-hand corner, then choose f of x, which is the expression. Again, we already have our table in here, and so then you'll find the mean of x1 and the mean of y1. If you remember, for the mean for the temperature, we took this and we rounded this to 99 degrees. And then for the sales, since it was money, we made that $79.65. But again, that's a really nice thing. Since you already entered your data, then just use it instead of going back and redoing that. Again, we did it in reverse order, but now that you're aware of this, hopefully that will be helpful for you in the future. So finally, this is how you can find the line of best fit as well as the correlation coefficient. It says you must enter this exactly as shown. So if you notice here, and I'm going to highlight this, you type in Y1, and then what's important here is this little kind of tilde. It's kind of saying approximately, because it's not the exact equation, but it's kind of the best one that we can come up with. And on your keyboard, it is to the left of the 1 on your keyboard. I think you have to use a shift. So you're going to type that in. So y, the little tilde, m, x1 plus b, and then it will find that equation for you. So it came up with our slope of 4.4, and I think that was relatively close. I think we had come up with 4.27. And then we did not come up with a b value for ours. We were just looking at the slope. And again, you've got something here called r squared. We're not concerned with r squared. We're just looking at the r value, that correlation coefficient. Notice it is 0.9715, which shows that we do have that strong positive correlation as we predicted, since the dots are very close to the line and we have that uphill progression. And again, as I said, here is our slope, and the slope that we had come up with, our slope we had was 4.27. That was when we used our averages of average temperature and average sales along with another point. And speaking of that average point, let's look at the next slide. You can actually plot your average point. And I showed you how to do this here. You literally just type in 99, 79.65, and then I decided to label it average point, just so you could see it. And this one happened to graph in purple, but I'm going to highlight that here for you. So that average point, and notice it's not exactly on the line, but it's pretty close, and that kind of, to me, makes a little bit of sense that it's not exact, because our slope, our approximated slope, was a little bit off from the actual slope that Desmos calculated for us. All right, so now it's time to practice. So these questions were taken from the workbook that you guys never received. It says create a scatter plot for the data in the table. So we have English scores and history scores. So it's wanting you to, by hand, make a scatter plot. Once you do that, it wants to know if the English and history scores have a positive or negative correlation. And also in question 13, do they have a strong or weak correlation? So on your own paper, if you have graph paper, that's awesome. If not, you can make a sketch. Remember to pay attention to the scale that you are using. Remember, if we have the first tick mark is 5, the second one's 10, 15, the next one needs to be 20. You can't jump around. We do have to count by equal increments, but we can count by different things on the x-axis and the y-axis as they did in the ice cream sales. I think one was counting by 5s and the other was counting by 20s. So at this time, if you'll pause the video, work through these 3 questions, and then when you're ready to continue, press play. Okay, so I'm assuming that you have now pressed play again and you're ready to look at these together. So when I look at this table, I notice English score is on the left and history score is on the right. I don't really think one depends on the other, but since English was on the left, I used English for the x-axis, and I used history on the y-axis. And if I look at these, the smallest English score was 44, and the largest was 70. And then for the history scores, the smallest was 57, and the largest was 67. And so I contemplated, like, should I make the corner be 0, 0? You know, is it really worth it? And in the end, I kind of decided, I think I'm going to use this bottom corner here as 40 in both cases. And I don't need a dot there. Let me erase that. So that's going to be 40 for each of these. And again, this was just personal preference for me. I believe I'm going to move that word English down. And again, for the English, I have to go up to 70. And so I don't have to really make these too close together. I think I'll do every 5 blocks. So that would be 50, 60, 70, and that's really as high as I need to go. I'm going to keep that same scale on the y-axis. If you're panicking that yours is different than mine, please don't. Again, this was just a choice that I made. All right, so now I'm going to plot these points as best as I can. So we have 60, 65. So English, if I make a 60 in English, then I should have a 65. So I think that's right. If I have a 53 in English, then I have a 59 in history. If I have a 44 in English, then I have a 57. In history. If I have a 61 in English, then I have a 61 in history. And then lastly, if I have a 70 in English, then I scored a 67 in history. So not a whole lot of data points here, but based on these 5 points, if we look at question 12, do they have a positive or negative correlation? And in my opinion, if I kind of thought about sketching in a line of best fit, it might look something like that. And that definitely looks to have these dots, even without drawing the line, the dots are definitely going up the hill, so this would be a positive correlation. And then those dots look to lie very close to my line, so I would say that this has a strong correlation. So again, this was all freehand. This was me coming up with the scale that I wanted to use on each of my axes. So let's look at question 14. Again, different scale. says which graph below shows the best model for the data that will create the best prediction, and explain why your choice is the best model for the data. Now notice there are more points, so this is not the data from the previous example, but if these were looks like we have 6 data points. So if I have these 6 data points, is line A part A the line of best fit, part B, or part C? Which one of those lines best fits that data? All right, hopefully we all agree that part C is going to be the correct one. That line best fits that data. Those points lie all really close to it. Line B, a lot of the points are above the line. In part A, that slope looks very steep. If we look at the distance here, this point lies really far away from the line, but in part C, all those points lie really close to the line. So when it talks about explaining the choice, I would say most of the points lie close to the line. So again, these pictures were taken from one of our graphing calculators in the classroom, just to give you a different kind of idea. And I know that some of you do have your own graphing calculators at home. So if you're interested in learning how to use your graphing calculator for line of best fit, if you don't remember from middle school or you've never done it, again, please feel free to reach out to me. I felt it was more beneficial just to work with Desmos. But I'm happy to do a Google Meet and show you with my graphing calculator. I can share my screen. Also, I'm sure there's plenty of YouTube videos that are out there that you can go and watch and learn from those. So that wraps up this week. Again, your homework is a Desmos activity. You'll go to student.desmos.com, and our code is E, V as in Victor, 8, G, S as in Sam, E. Again, please make sure you're using your Wake County Google account. It looks to me that only 10 of you, as of right now, did the activity from last week, but one of those 10, your name showed up as just the letter E, because you did not sign in using your Wake County Google account, so I'm not sure who to give credit for that. So again, please make sure that you are using that Wake County Google account. All right, guys, hope you have a great week, and please reach out if I can help you in any way. Take care.